Okay, so hopefully you've had a go at these. Most of them are just tick box exercises and you shouldn't find too taxing. So let's have a go. So we've got this car travelling and we've got 4 different forces acting on the car. The size of the resultant force on the car is 350 newtons. In which direction is the resultant force going to act? So we've got 800 newtons this way, 450 newtons that way, so we're going to have 350 going this way. So the answer is to the left. Complete the sentence by putting it across in. The car is. So we've got a bigger force here, unbalanced forces. Unbalanced forces can either accelerate or decelerate. So the unbalanced force is going in the direction the way the car is pointing. So that is going to mean it's going to accelerate. Done. Okay, draw another. We haven't talked about this, but we can certainly do it because it's very simple, hopefully. Draw another arrow on the diagram to show the friction forces acting there. So friction acts in the opposite direction to force. So an arrow there would do, an arrow there would do. Any arrow going this way would do. The airliner is accelerating. Which of these statements is correct? The friction forces are 0. The thrust is greater than the friction forces. The thrust is smaller. The thrust is the same size. So the thrust, so this is your thrust, propelling it this way. It's got to be greater than the friction forces. And last one, we've got a velocity time graph here. So even before you even tackle the questions, you should think, right, that's accelerating there. That's constant velocity. That's unbalanced. That's balanced. So you have to write it down in your exam, but in your head you should be thinking, right, I know what that means already. Let's see what the question says. Calculate the change in the velocity of the car in the first 5 seconds. 0 to 5. So 8 starts off at nothing, goes to 8. So the change is 8 meters per second. State the size of the resultant force between 10 seconds and 15 seconds. The size of the resultant force between here and here. Well, the forces are balanced. So whatever's acting this way is also going to act this way. The result will be 0. The resultant force will be 0. Okay? Hope you got an okay with those. Until next time, goodbye.